Hi guys, this is Terry here. In this video, I'm going to be going through some of the solutions for the January 2022 paper, right? So before you look at my solutions, I want you to please hit like and subscribe to my YouTube channel. Okay, let's start with question 1. So in question 1 here, by rounding each number in the expression below to one significant figure, estimate the value of this. So what they give us here, they give us an expression, right? But they want us to, before we do anything, we have to round it off to one significant figure, right? So let's try that. So 108 to one significant figure is going to be 100, right? That's one significant figure, right? And you're finding the square root of that, and then you're going to divide that by, so each of these numbers here, you're going to have to round it to one significant figure. So in the case of 19.72, I can round that to 20, plus if I round 5.296 to one significant figure, that is going to be 5, right? So this here is going to be, the square root of 100 is going to give me 10, and this is going to be 20 plus 5, that's 25, right? And this here is going to be 2 5s are 10, 5 5s are 25. So you can leave your answer as 2/5, or you can put your answer as 0.4. Next one, they want us to work out the exact value, and they want us to give our answer as a mixed number in its simplest form. So you can use a calculator to work this out, right? Or, so 3 and 3/8, I can write that as 3/8 24, that's 27 over 8, divided by 5 over 12. So if I want to add this here, that is the same as saying 5 over 12 plus, now 1/3, right, can be written as 4 over 12. So this here is going to be 5 over 12 plus 4 over 12, right? So this is going to be 27 over 8 divided by 5 over 12 plus 4 over 12 is going to give you 9 over 12. So this is going to be 27 over 8. When you're dividing, you have to change it and multiply and invert. So this is going to be 12 over 9. This 9 can go into this 27 3 times. 4 can go into this 8 2 times, and 4 can go into this 3 times. So this here is going to give me 3 3s are 9, 9 over 2, right? But I want to answer as a mixed number, right? So therefore, this here is going to be 4, 4 2s are 8, remainder 1. So that's 4.5, right? So let me just double check to make sure we don't have any errors there. So 3 and 3/8 divided by, open brackets, 5 over 12 plus 1 over 3. Are we going to get 4.5, right? So that part is correct there. The next part, they said, due to the COVID-19 pandemic, the number of seats available in a hall was reduced from 125 to 93. Calculate the percentage decrease. So percentage decrease, it's simply going to be whatever the change is. So you're going from 125 to 93. So your change is going to be 125 minus 93 divided by the original amount, which was 125, and you're multiplying that by 100%, right? That's going to give me my percentage decrease. So 125 minus 93 divided by 125 multiplied by 100, and I'm going to get 25.6%. All right, so that's my percentage decrease. The next one here now, part C, Micah invests a certain amount of money in the bank and pays compound interest, right? The bank pays compound interest at 2.5% per annum at the end of 2 years. Calculate her investment, sorry, At the end of the 2 years, the value for investment is $7,564.50. Now they gave us a formula, which is good, right? Some students can't remember this formula. They want you to calculate the amount that you invested, right? Now the amount that you invested is what they call P, or the principal, right? Now we're going to use that formula there, amount. So the amount in this case here, so we're going to write P multiplied by 1 plus, now it's 2.5%, so this is 2.5 over 100, and the number of years in this case is going to be 2, and that is equal to that amount there that she had at the end of the 2 years, 7564.50. So this here is going to be P, open brackets. Now 1 plus 2.5 divided by 100 is 1.025 squared is equal to 7564.50. So therefore, if you want to work out P, the amount that you invested, it's going to be 7564.50 over 1.025 squared. So this is going to be 7564.50 divided by 1.025 squared, and that's going to give me 7,200. So this is the amount of money that she actually invested, 7,200, right? So that takes care of question 1. Question 2, we want to simplify this, right? Now the paper that I saw, it's not very clear, so I will assume this is what we have. We have x cubed and you're trying to square that. So the answer in this case is going to be x to the power 3 multiplied by 2. So this is going to give me x to the power 6. So the rule that I'm using here is this: a to the m multiplied by a to the n. Sorry, wrong rule. A to the m raised to the power n is equal to a to the power m multiplied by n, right? In the second part, we have a division, right? And the rule for division when it comes to indices is this: a to the m divided by a to the n is equal to a to the m minus n. That's the rule. So what we're going to do here, you have the same base, you have y here and you have y here. So this is going to be y to the power 8 minus 5. So this is going to be y to the power 8 minus 5 is the same as saying 8 plus 5, and that is 13, right? Now, like I said, the paper that I saw is not very clear, right? So this could be, the question itself that I have here may not be what was asked, but the technique is the same. All right, the next one here, we want to factorize. We have two things to factorize here: xy minus y squared. So you're going to use the HCF method. So this is going to be y, open brackets, x minus y. So that's it. That's all you need to do for that one. That's the HCF method. In the second one here, that's the difference of two squares. X squared minus y squared is the difference of two squares. So I can write that as x plus y in one bracket, x minus y in the second bracket, right? So this is the answer for this. This is the answer for this. And they said, hence, simplify this expression here. Now, if you want to simplify this expression here, if you notice, the numerator is what we had in part A. So I can write that as y, open brackets, x minus y, all over x squared minus y squared can be written as x plus y by x minus y, right? So that means that this here will cancel with this, and your final answer is simply going to be y over x plus y, right? So that's part B. The next part of the question now, and CXC has brought something like this in the past. We have two rectangles, and they gave us the dimensions, but they said that the difference, right, between the areas of the two rectangles, right, is 64, right? So the first thing I'm going to do, I'm going to work out the area of each rectangle. So we're going to take this dimension and multiply by this. So that's x minus 3 multiplied by 3x plus 4. So this is x minus 3 multiplied by x plus 4. Sorry, 3x plus 4. Right? So we're going to multiply this out here. So what we have to do here, you're going to take the first term and multiply by the first term here. So this is going to give you 3x squared. Then I have to take this term and multiply by this. That's going to give you minus 12. Then we have this term by this. That's going to be minus 9x. And then we have minus 3 multiplied by 4. That's going to give you minus 12. So when I simplify this, I'm going to end up with 3x squared minus 9x minus 24, right? So that is one area we just worked out there. We need to work out the second area by using this dimension here and this dimension here. So that is x minus 3 by x plus 2. So this is x minus 3 multiplied by x plus 2. Yeah. Right, again, I'm going to do the exact same thing I did before. X by x will give me x squared. Minus 3 by x will give me minus 3x. 2 by x will give me... Actually, let me show you what I'm doing is. This by this. Then I'm going to take this, multiply by this. Right? So that is going to give me... Right, so x by x will give me x squared. X by 2 is going to give me plus 2x. So this here is going to be plus 2x. Right, then we're going to take minus 3 by x. So this is going to be minus 3x. And then minus 3 by 2, that's going to give you minus 6. So this is going to be x squared. 2x minus 3x is going to give you minus x minus 6, right? Now, that's the area of each of the rectangles. But in the question, they said that the difference, right? That means that when I take one area and I subtract the next area, I should get 64, right? So let's do that. Let's take the area of the first rectangle. That's 3x squared minus 9x minus 24. Right? And I'm going to subtract the area of the second one. Now you need a bracket here, or else you're going to make a mistake. X squared minus x minus 6 is equal to 64. Because it told us that the difference in area is 64. Right? Now, let's see if we actually get that answer here. Okay, so this is going to be 3x squared minus 9x minus 24 minus x squared plus x plus 6 is equal to 64. Let's carry everything on one side. So 3x squared minus x squared. Then we have minus 9x plus 8. And we have minus 24 plus 6 minus 64 is equal to 0. 3x squared minus x squared is going to give me 2x squared. Minus 9x plus x is going to give me minus 8x. And then I have minus 24 plus 6 minus 64. I'm going to get minus 82 is equal to 0. Right, now let me just double check that question there, make sure I don't have any issues with it. Give me one sec. All right, so it's x minus 3 by 3x plus 4. X minus 3 by 3x plus 4. And the next one is x minus 3 by x plus 2. X minus 3 by x plus 2. Right? Now let me just double check this before I work the final answer. So that's 3x squared minus Okay, so let's now. I have an error here. Hold on. Right, let me just do this over again here, right? So x by 3x is going to give me 3x squared. So this here is going to be 3x squared, right? Then x by, so this is going to be plus 4x, right? The next one is going to be minus 9x minus 12, right? So this here is going to be 3x squared, right? 4 minus 9x is going to give you minus 5x minus 12, right? We double check the next one to make sure. X squared, this is going to be minus 6, so that's minus 3 plus 2. Okay, so this is correct now, right? So this is going to be 3x squared minus 5x minus 12, right? Minus, again, put this in brackets, minus x minus 6 is equal to 64. So this is going to be 3x squared minus 5x minus 12 minus x squared plus x plus 6 is equal to 64. Carry everything on the left side. So you're going to have 3x squared minus x squared minus 5x plus x minus 12 plus 6 minus 64 is equal to 0. So this is going to be 2x squared minus 5x plus x is going to give you minus 4x. And last part is going to be minus 12 plus 6 minus 64. And you're going to get minus 70, right? So this is looking like we're going to get it now. So this is minus 70 is equal to 0. And what we're trying to do is to prove this here. But if you notice, they have x squared. So what they did, they divided everything by 2. So if I divide every single thing here by 2, I'm going to end up with x squared minus 2x minus 35 is equal to 0, right? So that's it. That's my answer there, right? Now let's do, that's question 2. Let's do question 3 now. So the following diagram shows 3 quadrilaterals P, Q, and R on a square grid. Q and R are images of P after it underwent 2 different transformations. So this is the diagram that they gave them. We have P, Q, and R, right? So they all are kites. That's a quadrilateral there. Now what we want to do now on the grid, draw the image of quadrilateral P after a translation of 10 minus 4. So where is P? So this is P here, right? This is P here. And the transformation is given by 10 minus 4. Right? 10 minus 4. Now, what this means is that we're going to make a movement in a particular direction, which is given by this vector here. So since we have positive 10, that means that you're going to move 10 units to your right, right? And the negative 4 means that I'm moving 4 units downwards. So let's check. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 units to the right. And then you're going to go 4 down. So 1, 2, 3, 4, right? Now that's the top part of the shape here, right? So that's going to be this, right? Now I want to complete the shape. So let me use a different color here, right? Let's use blue if there's anything. Actually, no, green. And so this here is going to be the location, right? Now make sure you have the correct, you're drawing the diagram correctly, right? and they told us to label that P prime. So this here is P prime. That's the image of P after undergoing that translation, right? So that's the answer for this one here. The next one, they want us to do a reflection in the line y is equal to 0. Now, you have to realize, wait a minute, the line y is equal to 0 is actually my x-axis, right? That's the first thing we need to realize, that the line y is equal to 0 is my x-axis. So that there is this. This here is your x-axis, right? Now, you want to reflect P in the x-axis, so you can choose any point that you want on the quadrilateral P. So let's say I choose this point here. Your mirror line is x. So that means that when I fold, if I were to fold this graph paper along the x-axis, P and the image should line up exactly. All you guys need to do is to look and see how many units this point is in front of the mirror line, which is 4 units. So therefore the image is going to be 4 units behind the mirror line. 1, 2, 3, 4. So this here is going to be the bottom of my image, right? Then you're going to do the same thing for the other points, right? And what you're going to end up with is this. It'll be this. Right? Do we need to label it? Did they say label it? Yeah, they said label it P double prime. So this here is going to be P double prime, right? Now visualize this. If you fold the paper along the x-axis, P and P double prime will line up exactly, right? So that's the answer for that part there. Now, the next part of the question here, right? I looked at the question. They said first, describe fully a single transformation that maps P as the original P, and you're going across the Q. So let's go to the diagram. So we have P and you have Q. Now, if you notice, the orientation of the quadrilateral has not changed. However, the size has changed, right? So therefore, we can clearly see that that's an enlargement, right? But if you have to describe an enlargement, what you're going to have to do is to state the center of that enlargement, right? So what I'm going to do, I'm going to locate the center of enlargement, which is pretty straightforward. All you're going to do, right, you're going to join, let's say, this vertex here. All right, hold on, let me just make this a little thicker. All right, so I have a line here, right? Now I'm drawing a line from this point here, right? And I'm going to pass it through the corresponding vertex on P, right? Then I'm going to use a second line, right? And we could probably use maybe this point. It doesn't matter which points you use, right? And I'm going to pass this through the corresponding point on P. So that's there, right? I can do it more than once if I want, right? If I'm not sure. Basically, when I join the corresponding vertices, right, they should all pass through the same point. And if you notice something here, you realize, wait a minute, they're all passing through this particular point here, right? This point here. And that is corresponding to minus 10, 7, right? So we need to locate the center of enlargement, right? Because it said describe fully a single transformation that maps quadrilateral P to quadrilateral Q. So we're going to say an enlargement right, of scale factor, because when we enlarge on something, we need to know what the scale factor is, right? Scale factor, right? Now look at the diagram here. Now, what I would do, I can look at this length here, right? And that is 1, 2, 3, 4, 5, 6, 7, 8, 9 units. But when I look at this one here, the original one here, it is 3 units. So that means the height of this quadrilateral has increased by a factor of 3, right? So the scale factor in this case is actually 3. So you're going to say enlargement of scale factor 3 with center of enlargement we just worked out this coordinate, so you're going to write that coordinate there, which is, what you got? Minus 10, 7. Right? So that's the answer for part 1. In part 2 now, we want to find the transformation, single transformation that maps P onto Q. Right? So let's go back to the diagram there. So I have, sorry, P onto quadrilateral R, right? So P onto R, let's go back here. So this is my original quadrilateral here, that's P, and this is where R is, right? Now, I've looked at this question all different ways, right? And I don't know, maybe it's me, but there seems to be a problem here. Because if you notice, the orientation has changed. When you do a translation, there's no change in orientation, so it's not a translation. If you do an enlargement, yes, you could get a change in orientation, right? Depending on the scale factor, like if it's negative, right? But in this case here, that is not what it is, right? So it's not a translation, it's not an enlargement, right? Because it's the same size. So the only two we left with now is rotation, right? And what am I missing again? A reflection. Right? Now that is not a reflection because there's no mirror line, right? So it can't be a reflection. So the only thing we left with is a rotation. But I tried constructing this to locate the center of rotation and I can't, right? So I don't know if there's a problem. If you all have any ideas, let me know. But I am not sure, right? What is this particular transformation, right? I am not sure. So that's question 3. Question 4, right? We have 2 lines here, L and M. Write down the coordinates of the x-intercept of line L. Now your x-intercept is where do you cut your x-axis. So that's going to be here, and that coordinate is going to be 6, 0. So the answer for this one here is going to be 6, 0. For part 2, they want the y-intercept of line M. So the y-intercept will be this coordinate here, which is going to be 0, minus 2. Right? So this here is going to be 0, minus 2. The common mistake that students make, they will put minus 2 and 0. That is wrong. Right? Next part. The equation of L is given by this. Find the value of K given that the point L is on the line. So you have an equation, x plus 2y minus 6 is equal to 0. And we have a point on the line which is given by 9K. Now, what that means is that x is equal to 9 and y is equal to k. That's what that means. So we need to substitute that into my equation for the line, right? Because if a point lies on a line, it must satisfy the equation. So in this case, it's going to be 9 plus 2k minus 6 is equal to 0, right? So 2k, 9 minus 6 is going to give me positive 3, 0. So 2k is equal to minus 3. So k is equal to minus 3 over 2. That's the value of k. They want the equation of m in the form y is equal to mx plus c. So which one is m now? Right, so m is this guy here, right? Now, if you want to find the equation of m, what you need to know the gradient of the line, and you need to know what is the y-intercept. Now, the y-intercept you already know as being 0, minus 2. So that means that c in that equation is minus 2. So the only thing I really need, I need to get a gradient. Now to get a gradient, I just need to use any 2 points on that graph, right? So I can use the same point that I have here, 0, minus 2, and I can probably use this one here, which is 3, 4, right? So 0, minus 2 and 3, 4. So 0, minus 2 and 3, 4. The reason why I'm selecting 2 points is to allow me to work out the gradient of this line, right? So let's label this now. let's call this x1, y1, call this x2, y2. So the gradient m, so your gradient m is equal to y2 minus y1 over x2 minus x1. So in this case, it's going to be 4 minus minus 2 all over 0. Sorry, it's x2, so it'll be 3 minus 0. So 4 minus minus 2 is going to give me 6. 6 over 3 is going to give me 2. So therefore, the equation of this line is going to be y is equal to 2x minus 2. That's the equation of the line M. Now, show by calculation that L and M are perpendicular. Now, whenever two lines are perpendicular, if I take the gradient of one and I multiply it by the gradient of the other one, I should get minus 1. Now, in the case of L, what is the equation of L? X plus 2y minus 6 is 0. X plus 2y minus 6 is equal to 0. So let's write this in the form y is equal to mx plus c. So 2y is equal to minus x plus 6, and therefore y is equal to minus a half x plus 3. Right? That's the equation of the line L. So therefore, the gradient is going to be minus a half. Right? So m is equal to minus a half. Right? So that's L. In the case of m, we just worked out what the gradient of m was. The gradient of m, we got 2. Right? So let's call this m1. The gradient of m2, is equal to 2. Right? Now, if I take the gradient of L and I multiply it by the gradient of m, right, it's going to be minus a half multiplied by 2, and you're going to get minus 1. So just because we got that, that means that they are perpendicular. Right? So that's all we need to do there. And the last part now, L and M represent a pair of simultaneous equations. Use a graph to write down the solution to the pair of simultaneous equations. Well, that's pretty easy. When you're using a graph to solve a pair of simultaneous equations, all you're doing is trying to find where do these two lines intersect. So in this case here, it's intersecting at 2, 2. So that's going to be your answer. So the coordinates, right, they intersect at 2, 2. So that means that x is equal to 2 and y is also equal to 2, right? So that is question 4. Question 5. They gave us a cumulative frequency curve. It shows the information about the times taken by 200 students to solve a mathematics Olympiad problem. Right? So we have cumulative frequency against time in minutes. Now, what do they want? Use the cumulative frequency curve to find an estimate for the number of students who took more. Now, you got to pay attention to these things. They said more than 50 minutes to solve. Now, let's go to the graph. Now, I need to get a line to help me read off these things, right? Any real exam, you're going to be using a ruler, right? That's the best thing to use. All right, so we're gonna have to take some measurements from the graph, right? So they told us that the number of students who took more than 50, right? Now that graph, the cumulative frequency curve, only gives us less than information, right? So we want for more than 50. So what we're gonna do, we're gonna go to the graph, and the first thing I'm gonna do is to read off where is 50. Now, some students had a little trouble with this because they didn't understand the scale that they did have, right? Now, this graph is not perfect, right? So I'm going to have to kind of estimate some stuff here, right? So according, now your answer is going to be slightly different depending on how you read off this thing, right? But let me show you what you're doing. You're reading off this value here. All right, the problem is that the copy that I have is not the best. Yeah, I'm having a little challenge here with this, right? But basically, you're going to read off at 50. Now, when I read off at 50, that is giving me about maybe 25 minutes, maybe? About 25. Let's say it's 25, right? So you read off that, you're getting 25 minutes, right? Now, no, wait, hold on, 1 sec. I read this wrong. Yeah, sorry. They said 50 minutes. So we're reading here first, right? So you're reading off at 50 minutes, right? Now, what the graph, like I said, what the graph is giving you is less than 50 minutes, right? Now, according to that there, that is corresponding to around 196, right? Now, you need to understand the scale here and you need to know your scale here. If you don't know the scale, then you're in trouble, right? All you had to do was take 20 and divide it by the number of lines that we have, which is 5, and you're going to get 4. So every small line represents 4 units. So this point here that I'm reading off on the graph there, right? That looks like it's corresponding to about 196, right? So in this case here, it's going to be 196. That is the number of students who solved it in less than 50 minutes. So what you're going to do, you're going to say 200 minus 196, and you're going to get 4 students, right? Now they say estimate, so it depends on how you read off the graph, and I don't have the best graph here, right? The next one, they want the median time to solve. So you have to go to the graph again, right? You want median. So if you want median, you have 200 students in total. So what you need to do, you need to read off at 100. So that's here, right? As you can see, the graph is not perfect, right? But you're going to read off at 100, and that is going to correspond to about 31, 32, 33, maybe about 33, right? Maybe about 33 minutes. So I'm getting a median of around 33 minutes, right? And the last part, the probability that a student chosen at random took at most 28 minutes. Now, when you see something saying at most 28 minutes, right? That means you're looking at 28 minutes or less. That's what that means. 28 minutes or less, right? So all you're going to do, you're going to go to the graph and you're going to read off where is 28 minutes. According to my graph here, 28 is corresponding to around, to me it looks like about 64, right? It looks like around 64. So the probability is going to be 64 over 200, right? And that is going to be 8 over 25. Right? So that's your probability there, 8 over 25. All right, now they want us to use the cumulative frequency curve to complete this table here. Now, when you have a cumulative frequency curve, you can work backwards and work out what your actual frequencies are, right? Now, the first one here, right? Now, remember, when you're doing a cumulative frequency, we're looking at upper class boundary against cumulative frequency. That's what we normally plot. So what we're really looking for, we're looking for 10.5 on the graph, 20.5, 30.5, 40.5, 50.5, and 60.5. Those are the values we need to read off what the actual cumulative frequency is, right? Now, what they did, they gave us the first frequency here, which is 12. Now, when I look at the graph here, right? Let me see something. That should correspond to 10.5, right? But when I go to the graph there, right? When I read off 10.5, I don't know if they read in their graph correctly, because this is 10, this here is 11, right? And they are getting 12 as their answer. 4, 8, 12. 12 is corresponding to 10, not 10.5, right? So we're going to follow what they have, and they actually have 12, so I'll leave it as that, right? the next thing we need to do, we need to read off at 20.5, right? When I read off 20.5, right, you're going to go to the graph and you're going to read off at 20.5. Now, based on the graph there, I'm seeing this being represented as 36, right? However, if we look at the data in the table, it can't be 36, right? It can't be 36. So let me just show you what I would have done, right? What they are expecting us to get is 38, right? So these here are my cumulative frequencies I would read off from the graph. And you are working backwards to get a frequency. So the first cumulative frequency will correspond to 12. That's my frequency. Now, if you read off from the graph and you got 38, sorry, to get the actual frequency, it is going to be 38 minus 12. 38 minus 12 will give me 26. So that's the answer for this part here. When I read off and I get 80 this time, right? That's the next value I'm reading off from the graph. So 80, right, minus 38 is going to give me 42. So we're good, right? When I read off the next one, I'm going to get 164, right? 164 minus 80, right, is going to give me 84. So we're good there. When I read off the next one, I'm going to get 196. So 196 minus 164, I'm going to get 32. And then the last one, we're going to get 200. So it's going to be 200 minus 196, which is 4. So the two numbers that we need to complete the table, right, will be 26 and 32. So let's go back here. So this here should be 26 and this one here should be 32, right? But like I said, I don't necessarily agree with this. I think they've read off something wrong on their graph, right? So we want to complete the table. Now, we have midpoint, we have frequency, and all we're doing in this column here is multiplying midpoint by frequency, right? So 15.5 multiplied by 26, I'm going to get 403. And then for the last one is going to be 45.5 multiplied by 32, and you're going to get 1456, right? So that's it to complete our table. The last thing that they want now, use the information to estimate the average time. So what we're trying to work out here is mean, right? And all we need to do to work out mean, right? Your total number of students, your sigma F, should work out to 200, right? They told us it's 200. You have sigma XF, meaning that when I add up everything in this column here, right? Let's see what I get. So that's 66 plus 403 plus 1071 plus 2982 plus 1456 plus 222, and you're going to get 6,200, right? So I have sigma XF and I have sigma F. So you want to get estimate the average, so that's mean. So your mean is given by sigma XF over sigma F, which in this case it's going to be 6,200 over 200. Right, which is going to give you about 31 minutes. Right, so that's going to be your mean time taken for them to complete the question. Right. All right, so that is question 5. All right, moving on to question 6 now. So question 6, we have a shape here. Right, they told us to take pi as 22 over 7. Always take pi as whatever they tell you to take it as. So the diagram shows a scale drawing of a running track. It consists of a rectangle and two semicircles with diameters LN and MP. So they give us some dimensions here, right? Just now, let me double check something here. I see I have 96 and 98. Hold up. All right, so it should be 98. All right, so this should be 98 here. All right, so we have this track here, right? What do I want from it? they said show that the total length of the track is 350 meters, right? So the length of the track we're talking about here is this, the perimeter of the shape. That's essentially what we're doing. Now, this here is 98 meters on this side, right? So all I really need to do is to figure out what is this curved piece here, and I need to figure out what is this curved piece here as well, right? Now the thing is, those two curved pieces are going to add up as if we had one circle, right? So let's find the perimeter of a circle, right? Or the circumference of a circle, right? Now the circumference of a circle is given by 2 pi r. So it's going to be 2 multiplied by 22 over 7 multiplied by the radius. Now let's go back to this thing here. So let me double check, is 49, right? 49, yeah. Right, so what you're going to do, you need to know what the radius is. So the radius is going to be half of 49, right? So this is going to be 49 over 2, right? Now, what's going to happen is this 2 will cancel with this. This 7 could go into 49 7 times. So this is just going to be 22 multiplied by 7, and you're going to get 154. Right? So that gives me the two curved pieces. So the length of the track right is simply going to be, go back to the diagram, you have to take this 98, add it to this 98 and to the answer we just got. So it's going to be 98 plus next 98 plus 154, and you're going to get 350 meters, right? Which is what they told us to prove. They said prove that the total length of the track is 350, right? So we're good there with that. Now, Nathan walks at a constant rate of 1.4 meters per second. So this here represents his speed, right? This is his speed here. Now calculate the time it will take him to walk 7 laps around the track. So the total distance is going to be 7 multiplied by 350, because every time you make 1 lap, it's 350. So this is going to be 350 multiplied by 7. That's going to be 2450 meters, right? So that's distance. You know what speed is? Speed is 1.4 meters per second, right? Now the formula for speed is distance over time. What I want here is time. If I rearrange this formula, I'm going to get S multiplied by T is equal to distance. So therefore, time is simply going to be distance over your speed. So that's going to be 2450 over 1.4. And that's going to give you about 1750 seconds. Right? So that's his that's the time taken for him to make 7 laps around the track. The next part, Tafari runs 1 lap of the track in 68 seconds, right? Determine the number of laps so Tafari can complete in 1 hour, right? Now, all we need to do here is to figure out how many seconds do we have in 1 hour, right? So 1 hour is going to be, you have 24 hours, right? Multiplied by 60, that'll convert 24 hours into minutes, and then we have to multiply by our next 60, and that is going to give me, right? Oh wait, what am I doing? My bad. All right, 1 hour, right, is simply going to be 1 multiplied by 60 multiplied by 60, right? So this is going to be 3600 seconds. Right, determine the number of laps. Right, so number of laps is simply going to be 3600 divided by 68. Right, and you're going to get 52.9, right? You're getting 52.9 laps. Now, they said, how many laps will he complete in 1 hour, right? If you notice something here, he's not going to make it to the 53rd lap. So your answer, right, the number of laps is going to be 52 rather than 59. You're not going to round up, right? Because the time ran out, right? 1 hour came before he was able to finish the 53rd lap, right? All right, so that's part 1. Part 2 now. Nathan completes running 1 lap every 72 seconds. Tafari and Nathan start running at the same point, L, on the track. Each completed a number of laps, right? Calculate the least number of laps that each will complete before they are both at point L again, right? So you have Tafari going around in laps, Nathan going around in laps, but each of them, they are completing it in different time intervals. So one of them is completing in 72 seconds, and the next one is completing in 68 seconds. Now, I know some students may have been thinking, well, what do we need to do here, right? Now, this question is based on LCM, right? You have a lap being completed in 72 seconds and 68 seconds. So what we need to do, we need to work out what is the LCM, right? What I will do is give us the time at which they will meet up again. Because they said they want the number of laps each will complete when they are the same time, right? So let's find the LCM here, and I'm going to do division to work it out here. So divide by 2 first. So this is going to give me 36, and this is going to give me 34. Going to divide by 2 again, right? We keep dividing until we end up to 1 as our answer. Now, 36 divided by 2 is 18. This here is going to give me 17, right? Then try 2 again. This is going to give me 9, right? This can't divide, so we leave 17 there. We're going to try 3 now. So this is going to be 3, and this is going to still be 17. Then you're going to try 3. You're going to get 1, and then you're going to get 17. And then the last thing I'm going to do is to divide by 17. You get 1 here, 1 here. To get my LCM, all I need to do is to multiply all these numbers here. So the LCM, right, is going to be 2 by 2 by 2 by 3 by 3 by 17. That is going to give me 1224. So this time here, this 1224 actually corresponds to the time at which they're gonna reach there at the same time, right? So we need to figure out how many laps Tafari completed. So in the case of Tafari, all you need to do is to take 1224 and divide it by the time he takes a complete, or she takes a complete 1 lap, which is 68. So 1224 divided by 68, you're gonna get 18 laps. Right, so this is 18 laps here, and the next one is Nathan, and Nathan is going to be 1224 over, he's taking how much? 72. Right, so 1224 divided by 72, you're going to get 17. Right, so 18 and 17 laps, that's what we're looking at there. Right, so that takes care of question 6. Question 7, the grid below shows the first 3 figures in a sequence. So we have small squares of unit length, and we have colored, that's shaded, and we have white, right? Now, if you study the pattern here, what you notice is that the solid colors are on the diagonal and on the top row, right? So watch carefully. You have these here colored, and then you have this colored here. So you have the diagonal colored and the top colored. Diagonal colored, top colored, diagonal colored. Right? Now, what they want us to do now, they want us, in the space below, draw the figure 4. So, based on what we know, right, I'm going to have to shade here. Right? So, I'm shading the diagonal first. These are easy to mark, sir. Wait, 1 second. Why is this looking so... 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 7, 8, 6. All right, so they gave us a little more boxes than we actually needed, right? So this figure here is going to be this here. Right? That is going to be figure 4, right? Because if we look at the boxes here, in the first figure, you had a 3 by 3 square. The next one, you had a 4 by 4 square. And this one here, it's a 5 by 5 square. So for this one here, it should have been a 6 by 6. So 1, 2, 3, 4, 5, 6. Yeah, that's up to this point here. Yeah, so this here is my figure. They kind of gave me some extra boxes there that I really don't need. But that's figure 4. All right. Next part now. They give us a table. So we have to analyze the pattern here. So we have right, so we have figures, we have number of colored squares, so that's the shaded, we have perimeter, right, and we have total number of squares. So the total number of squares would mean how many that's colored and white. All right, now what I normally tell my students in this case here is to work out for your final, for figure n. Once you know that, it's easy to work out the pattern. Now, let's see what's happening here. So when I jump from 5 to 7, I'm adding 2. When I jump from 7 to 9, I'm adding 2 as well, right? In this case here, you're going from 12 to 16, so you're adding 4. And then you're going from 16 to 20, and you're adding 4. So normally when there is a pattern like that, where there's a constant number being added, that's going to appear in your formula somehow, right? And if we look at the last column with number of squares, you realize that your figure number is equal to this first number here. Figure 2, that's this first number here. Figure 3, that's this first number here. And in all of them, we are adding 2 and we're squaring it, right? So I can do this one first. I can say this here is going to be n plus 2 squared. That's what's going to go here, right? Now let's come up with the formula for the number of colored squares. Now that addition of 2 all the time has to come into play somehow. So let's see. Let's say 2n plus 3. Is that making sense? 2 3s are 6 and 3 is 9. Now, whenever you come up with your formula, double check it with your values, right? So 2 by 1, that's 2 plus 3, that's 5, so we're good with this. 2 by 2 is 4 and 3, 7, we're good. 2 by 3, 6 and 3, we're good, right? So you notice this 2 appeared in your formula. So for this column here, right, where we have a constant number of 4 being added, that 4 must appear in the calculation somehow. So this is going to be 4n. Let's see, 4n plus what? 8. Yeah, 4n plus 8. That'll work. So 4 by 1 is 4. 4 plus 8 is 12. 4 2s are 8 and 8 is 16. Yep. 4 3s are 12 and 8. Yeah, so we're good. So I have my formula. I can basically work out anything I want now, right? So we want to work out for this row here where n is 11. So this is going to be 2 by 11 plus 3. So that's 22 plus 3. You're going to get 25. So 25 is the answer for that one. For this one here, it's simply going to be 11 plus 2 squared. So that's going to be, that's what, 13. So 13 squared is 169. So this is going to be 169. So what we missing now? All right. So we can figure out the figure number here by using this 49. So all I'm going to do is say 2n plus 3 is equal to 49. So 2n is equal to 49 minus 3. So 2n is equal to 46. And n is 46 over 2. So n is equal to 23, right? So this here is going to be 23. Next thing we need to work out, what's coming here. So that's 4n plus 8. So that's 4 by 23 plus 8. and that's going to give me 100, right? Now, usually these tables are worth plenty marks in the exam. This table here was worth how much? 3 and 2, 5 and 2, 7 marks, right? So that table was worth 7 marks. Easy 7 marks, right? On the last part of the question now, they said, how many white squares are in figure 11? Now, if I go to figure 11, oh, we have that in the table here, right? You have 25 colored squares, and the total number of squares that you have is 169. So all we're going to do here is take 169 and minus 25. That's it. 169 minus 25. And you're going to get 144. So that's how many white squares that we're going to have, right? All right, guys. So that brings us to, that's the solution for questions 1 to 7, right? So please do me a favor, hit like and subscribe, right? And yes, I do give online maths, chemistry, physics, and advanced classes, right? So take care, guys. All the best.